Hey guys, Mr. Jenkins here with kind of the last official lesson of Chapter 4. We'll have kind of an extension lesson on Friday, tomorrow, that's kind of just more on 4-6, and really tomorrow's is going to be more like an extension of the study guide. So with that said, we're coming close to the end of the chapter. And this will be your last Math Excel, is section 4-6 Math Excel. Your learning targets for this lesson are that I can determine whether a relation is a function, so identifying functions, and then finding domain and range and using function notation. Some vocab words that you might hear: relation, domain, range, vertical line test, and function notation, which we kind of mentioned function notation on yesterday's extra practice activity. All right, so example 1 is about identifying functions using mapping diagrams. All right, so really, I don't love mapping diagrams, if I'm being honest. So I'll show you how to do a mapping diagram and how to read it, but I'll show you also the easy way to identify whether or not a relation is a function. Okay, so when we're thinking about functions, we're thinking about inputs and outputs. So inputs are x values, outputs are y values, right? And the variables don't really matter, but when we're thinking about an equation like y equals mx plus b, that's kind of what I refer to as x is the input, y is the output. All right, so let's go ahead and write out a mapping diagram. Okay, so my inputs are each of the first numbers of the ordered pair. So -2, 0, 4, and 5. And I apologize if this is difficult to read. -2, 0, 4, and 5. All right, so they kind of circle this when they show it in the book. So that kind of is the what we would call the domain. Domain is the set of input values. And then the range is the set of output values. 0.5, 2.5, 6.5. And then there's another 2.5. So we do not write the repeats here. So I'm only going to write 2.5 once. So I'm going to write out my range as 0.5, 2.5, and 6.5. Just remember, do not write the repeats there. So this represents my range. And now we have it set up to kind of draw our mapping diagram. All right, so all that means is that we represent each ordered pair by an arrow. Okay, so this ordered pair right here says -2 maps to 0.5. I'm going to draw that with an arrow. -2 maps to 0.5. I don't know if you guys have ever seen the function machine video, but that's like -2 goes in, 0.5 comes out. This one says 0 goes in, 2.5 comes out. 4 goes in, 6.5 comes out, and 5 goes in, 2.5 comes out. All right, so now the last question is it a function? All right, so the answer here is yes. All right, so I'm gonna go ahead and write yes, and then I'll tell you why. The official answer is because each input maps to a unique output. You might be thinking, how is that? What does that mean? Because it looks like 0 maps to 2.5 and 5 maps to 2.5. So what's he talking about there? Each input maps to a unique output. So the only thing that can't happen is you can't have two different inputs that go to you can't have one different input that goes to two different outputs. Okay. So a repeated range value or a repeated output value is okay. A repeated input value makes it not a function. So this is a function. All right, so that's how to do a mapping diagram. Now, on B and C, I'm just going to show you without a mapping diagram how to quickly kind of tell. All right, and there are mapping diagrams or something like a mapping diagram on the filled out notes if you like to use that. All right, so looking at the relation in problem B here, it says 6 maps to 5, 4 maps to 3, 6 maps to 4, and 5 maps to 8. All right, so I can quickly tell you without a mapping diagram that this is not a function, or no, and here's why. Because it says 6 maps to 5 and also 6 maps to 4. Really, if you see a repeated input, that's going to be a no. Why is it a no? Because 6 maps, or you could say 6 corresponds to, I like maps, 6 maps to 5 and 4. So again, back to the function machine video, that would be I put 6 on the conveyor belt, and one time it goes to 5, and then I put 6 on the conveyor belt again, and then another time it goes to 4. So at that point, we know that's not a function machine, right? This is just a relation, not a function. All right, and I will leave C for you, right? So now the question in the video is going to be, is this relation right here a function? If you can't clearly see it in the video, I suggest pull it up on the notes to answer the question. All right, so moving on to the next example, we're gonna use the vertical line test to identify functions here. Okay, so I'm gonna go ahead and graph these points. -4 maps to 2. Make sure I'm counting my ones there. Yeah, we are. So -4 maps to 2. That's that point. -3 maps to 1. 0 maps to -2. -4 maps to -1. And 1 maps to 2. Sorry you can't see these as I'm graphing them. That'd be a lot more useful. Anyways, there they all are graphed. Now, a lot of people would just say no right off the bat because this is not linear, right? This is linear, but then these two are off the line, right? But that's not really how you do these, right? So remember, we're looking for, does each input map to a unique output, right? And we can test that on a graph by using the vertical line test. If there's a vertical line that we can draw that touches more than one point, it is not a function. So this vertical line right here, also known as x equals -4, touches 2 points. So this fails the vertical line test. So this would be a no. Now, if you got what I was saying before, really you could tell that just by looking at the points, by looking at the relation, because you see a -4 input value there and a -4 input value there. But here's how we can tell kind of graphically for you more visual people. Next one, I'm not really going to worry too much about how to graph the points. I'll just punch it into my graphing calculator. I know you don't have one of these, but any that's like this on the, let's see, on the homework will be already graphed for you. But I'll just show you kind of what a graphing calculator can do here. So -x² + 3. So I go to y equals to type that in. Again, I know you don't have one of these, but -x². And then +3. So I typed in my function rule, and I can just hit graph. And there we go. So there's a good picture of it. Just to be really precise, I'm going to look at the actual points that I can fit on my graph. So it says -2. -2 maps to -1. We have -1 maps to +2. And we also have 0 maps to 3. 1 maps to 2. And sorry, 2 maps to -1. So that'll give me a nice accurate graph. When I go back to the graph, I can tell that it looks like it just goes down and down forever. I'm just going to go through my guide points there and just put an arrowhead there. All right, so the question is, does it pass or fail the vertical line test, right? Well, look at your grid lines. Is there any grid line that hits this graph in more than one place? The answer is no. It's kind of maybe difficult to tell because it looks like, well, eventually it'll go straight up and down, but it never quite goes straight up and down, okay? So the answer here is yes, it passes the vertical line test, so it is a function. All right, so I'm going to ask you again, looking at C, is it a function? And you can either use the graph on the notes to answer it, or you can just answer by looking at the ordered pairs. 0, 2, 1, -1, -1, 4, 0, -3, and 2, 1. Really, the question is just, is it a function? Yes or no? All right, moving on, evaluating a function. So this one says the functions, I think that should just say function, w of x. Remember we talked about how to say that yesterday. That's w of x is equal to 250x, represents the number of words. So w of x is defined for us. That's the number of words you can read, and that's going to say x minutes. So x stands for minutes. And it wants to know how many words can you read in 8 minutes, right? So this is an easy question to answer. What we need to focus on, though, is the function notation part of it. In function notation, they're telling me to find w of 8. And what that means is we take our function rule, and if I replace x with an 8 here, that means I have to do the same thing on the other side and then simplify the other side. So 250 times 8 is what w of 8 equals. And we'll just type that in. 250 times 8 is 2,000. I'm out of room on my screen, so I'll just write that underneath. And since this is a word problem, I'm going to put my answer into context, right? My two variables are w of x is number of words and x is minutes, right? So what's equal to 2,000? That would be w of 8 is equal to 2,000. So this is talking about my output variable. So this would be 2,000 words. All right, and then I'll do one of the next two. It says the domain of f of x equals negative 1.5x plus 4 is 1, 2, 3, 4. And so what's the range? All right, so for this given domain, what is the range that goes with it? Let's just find out. So we want to find f of 1. We want to find f of 2. We want to find f of 3. And then we want to find f of 4. All right, so we'll let our calculator do the work for us so we can go pretty quick. So f of 1, and I wrote all this out on the notes so you can get a more visual on the notes, but all we're doing is we're going to take negative 1.5 times my input, which here is 1, plus 4. That's the rule. Multiply your input by negative 1.5, add 4. So 1 goes to 2.5. 2 is going to go to negative 1.5 times 2 plus 4. So 2 goes to 1. 3 is going to go to negative 1.5 times 3 plus 4. So 3 goes to negative 0.5. And now we start to see a pattern, right? We're decreasing by 1.5 every time. So if I just follow that pattern, then that would tell me that 4 is going to go to negative 2, right? And obviously I could just punch that in. You don't have to necessarily see the pattern and follow the pattern. So to formalize my answer here, I would say that the range, we use R for that, is these four numbers. So here's how you use set notation: -2, comma, -0.5, comma, 1, comma, 2.5. And then these little things are called brackets, right? Also notice I flipped the order. Usually in set notation, you go from least to greatest, and you never write repeats. Example B is worked out on the filled out notes. I suggest maybe you try that one on your own and then check it. That's a good way to do a self-assessment on, am I getting what Mr. Jenkins is saying? Am I picking up what he's throwing down? All right, last one, and you'll struggle with this one on the notes or on the homework probably because they don't give you a graph. So you might have to refer back to this video. Let me zoom in on the graph too so we can see it one time just for the scale. So I know it's tough to see, but we go from 0 to 60. So we're counting we're counting by 60s on the f of x axis or the d of x axis, and we're counting by 2s. That's 2, 4, 6. Let me just darken that in a little bit, at least the first one. So counting by 60s there, counting by 2s on my input axis. I'm going to zoom back out so we can see the rest of the word problem. It says a car can travel 32 miles for each gallon of gas. Usually that would just say car travels 32 miles per gallon. The function d of x equals 32x represents the distance d of x in miles that a car can travel with x gallons of gas. And it makes sense here that distance depends on gallons of gas, right? So that's why this is my output, this is my input. The car's tank can hold 17 gallons of gas. What domain and range are reasonable for the function? And then what is the graph of the function? All right, so we've got to think here, right? So we got to think about which inputs could we kind of use here, right? So which values for x would make sense? Could I plug in like -1, for instance? The answer there would be no. I can't plug in -1 because you can't have negative gallons. Could I plug in 0? Yes, you could have potentially an empty tank in theory, right? In real life, you know, you're never going to get to absolutely 0. You're always going to have some kind of residue. But just for the purposes of this problem, we're going to say you can get all the way down to 0. So I'm going to just kind of say what would be reasonable for our inputs. So we said x equals 0 would be reasonable. And then what's the maximum value? So that can be found right here. My tank can hold 17 gallons. So I could go up to x equals 17 and then everything in between, right? Another way to say that would be that my reasonable part is everything in between 0 and 17, which we can show with an and inequality. So that can be written out that way. And we'll refer back to this at the end. Okay? So if I sub in 0 to my function rule, what is d of 0? Now we got to get our outputs, right? So 32 times 0, that's easy enough. That's going to be 0. Okay? So remember, this is a point on the graph, 0, 0. That's going to be kind of my lower limit point. We also want to find d of 17. That represents my upper limit point. So that would be 32 times 17. I'm not going to waste time trying to multiply that out by hand. I'm just going to type it in. So it says 17 maps to 544. So on a graph, that's just the point 17, 544. Okay, so on my x-axis, remember I'm counting by 2, so this is 14, this is 16. So, sorry, this is 16, this is 18, so here would be 17. And 544. All right, so we're counting by 60s. This is 540, this is 600, so we're going to be just above the 540 line, right? So right about here. You just kind of do your best to show that. And I'm going to let the screen catch up so you can kind of see everything. So this is the point, and I'm going to write that out, 17, 544. That's my end point. I'm not going to draw my line going through there. That's my end point, right? So this is a line segment, not a line. So I'm going to draw a nice straight line. You should use a straight edge if you were doing this on paper. All right, so that is the graph that represents, I can look at it real quick and see if I have 4 gallons of gas, how far could I travel? Looks like just over 120 miles. If I have 8 gallons, looks like, just over 240, right? So that's basically what I can tell from the graph. And then the last part is kind of the formalizing part. How can I write out the domain and the range? Well, I've already done the domain, okay? So you can't just say, what people want to do is they'll say 0, 2, 4, 6, 8, 10, 12, 14, 16, and 17. Right? That's not true though, right? Because you could have 0.5 gallons. You could have, 10.2 gallons, right? You got to have all your decimals there too. So the only way to really show that is this way, or we've talked a little bit about interval notation. So you could also say from 0 up to 17 in brackets, okay? So this is my domain. I'm not sure. I think MathXL will probably want it this way. And then my range is my lower and upper limit. So my range goes from goes from 0, 0. So my y is 0 up to 544. All right, so that would be an and inequality that looks like this. So I'm going to wait till it pops up, and then I'll talk about what I wrote down there. It says that d of x has to be greater than or equal to 0 at any given time, and d of x has to be less than or equal to 544. That's the max distance I could travel, right? So that's basically what we're saying there. The only other way to really say that, to include all of your outputs, would be kind of like this, use an interval notation. So you could go bracket 0, 544, close with a bracket. All right, so that will conclude our lesson. Like I say, we kind of have a follow-up lesson to this, which kind of transitions us into our study guide. So I'm thinking probably test sometime next week, probably I'd say either Thursday or Friday. So make sure you're getting those MathXLs finished, because a looming test date means a looming due date for your MathXLs. Besides that, hope this helps. You all have a nice day.